Hi everyone, I am Sai Krishna. I'll be the instructor for this project. In this project, we're going to learn how to create a tic-tac-toe game with Python using Minimax Algorithm. This project is designed to be easy to understand, especially for beginners, and this will be the outline for this project. So let's get started. So let's see what is tic-tac-toe game. I will just give you a quick demonstration so that you can understand like how this game actually works. So tic-tac-toe game is a two-player game. It is a simple game which is based on a 3 by 3 grid. The goal of the game is to get three of the symbols. So you can be either X or O. Suppose if we are X, the other player will be O. So the goal is to get our symbol like three times in a row, or like either vertically, horizontally, or diagonally. So let's play this game. So we can't win here, so let's keep it here. And okay, let's try this position. Okay, I blocked this. So this is a draw. But if we were able to get all our symbols in a row, then we will win. So this is how this game actually works. So we are going to create the game using Python, and our opponent will be an AI player which never loses. So we are going to create that AI player using Minimax algorithm. So what is Minimax algorithm? We will see. So Minimax algorithm is a decision-making algorithm mainly used in two-player games like tic-tac-toe. It helps a player to make best possible move, assuming the opponent will also make optimal move. So we will use this algorithm to create this AI player. For demonstrating the Minimax algorithm, we will just see this tree. So Minimax algorithm, as we discussed, mainly used for two-player games, so that one person will try to win against the other person. So one person will take one step, and the next person has to take the other step, and it will go on like that. So now, as you can see, 0, 1, and like min, max, it is like that. That means each player is taking their own turn. So now, first, let's consider this. For example, we have these numbers like 20 plus infinity minus 10, 9, 8, minus 8, 8, 8, 6 plus infinity minus 10, 5. So if this is a min player, like if it is one like a player who is trying to get a minimum score, then we will choose this 20 because 20 is less than plus infinity. Suppose if it is like in this case, the minimum is minus 10. So it is minus 10 here, and here it is minus 8, and here in it is not, no number is there, it's only single number, so it will be 8. And here you can see there is 6 and plus infinity, so we will take 6. And here we will take like in minus 10 and minus 5, minus 10 is smaller, so we'll take minus 10. And here now the turn is the max player's turn. So max player, if he has to pick, the max player will try to pick up the maximum number, so it will be 20. And here the max player will try to pick up this minus 8, because minus 8 is larger than minus infinity. The same way here he will try to pick up 8, and then here he'll try to pick up minus 10. And again the turn will be the min's player turn. So minimum player will try to pick up something minimum of these two. It will be minus 8, and then it is minus 10 over here, and here it is minus 8 from comparing both. This will be taken by the max player. So if this max player has to pick up a move, like if he has to pick up some number in all these numbers which make him win, then he will choose this minus 8. So this is how like the minimax works. So we will compute all the possible outcomes, Like we will also simulate an environment, like we will simulate all the moves, like the opponent moves, and we will check everything, every possible move, and based on that we will make a decision, like which number to pick. So this is how the Minimax works, and we will try to apply the same logic in for tic-tac-toe. We will try to compute all the steps that are possible, and based on that we will take a move. So that is how this Minimax is used. So let's see like how that is implemented inside Python using this Minimax algorithm. Firstly, we will set up our Python environment. If you haven't downloaded already, then please go to the Python website and download the latest version of Python and then install it. Once you are done with that, please go to your favorite code editor and create a file like tic-tac-toe.py. You can create it inside any folder you want. So let's start writing the code. Firstly, we will start by writing some board management functions. So now let's create some functions to manage the game board. Like we will create some functions for checking, like if a move is valid, we will like for printing the board, for checking the winner, checking if the board is full. So these are some utility functions which will be used in our main logic. So let's create these board management functions first. So first of all, I have to import some type hints because I'm going to use some type hints here. Toward. So this will be our board, and let's see what it actually prints. So if name is equal to main, then run create board. Okay, Python. For running this program, you can check it by take like this Python tic-tac-toe.py, and it is not printing anything, so I have to do this. So the create board function actually creates a two-dimensional array with this element. So it will be a 3 by 3 grid. So it is creating the grid which is required for tic-tac-toe. So now let's create another board management function. Define print board, uh, board which will take this board as parameter, and it will be list of string, and it will return none because it is a print function. And this prints the tic-tac-toe board. Then for row in board, we will print the row by joining this particular character, join of row. And there is some issue here, the spelling mistake board. Okay, this is looking good. After that, we will just give some characters. Yes, save. Now if I just print the board, print board is equal to create board, and then if I pass this print board of board, this should print the board. As you can see, it is printing the board. And now it's time to create some other board function to check if the move is valid. So if a player is trying to make a move, we need to check if the move the player is making is valid or not. So if move is valid, so we will pass one parameter as board, and then other parameter will be row count, the like row index and column index, and the return value will be like a boolean, because it will be either true or false. And here, just adding some documentation for this, checks if the given move is valid or not. Then we will just see if the board of row of column is equals to this empty space. So if it is an empty space, then we can make a move. So that way we are checking the move. And now let's create some other function, make move, and it will take board as parameter, and then the second parameter should be the row index, and then column index, and then the player, either X or O. And I'm considering we will be the X player and AI will be O. So we will do that as well, and it will return none, because it will make move. It will just make move. It doesn't do anything. Like it doesn't have to return anything. So it places the player symbol either X or O at a given position. Okay. So what we'll just do is like we will put it like row of column, and we'll keep it player. That's it. And we will create one function is winner to check if the player is like if there is any winner by now. So we will pass board. Then we will need a player string, and it will return bool, because it will either return true or false. So this will check if the given player has won the game. And so first we will check vertically and horizontally, then we will check diagonally. So for checking horizontally and vertically, this is what I'm going to do. For I in range 3, I'll go through each, I'll take I, and I will be 0, 1, 2, and I'll check if all of, I'll take a list, cell is equal to player for cell in board of I. So this will check like horizontally. For each row, I'm checking it is checking row wise horizontally, like whether all the cells in that particular row are belongs to this particular player or not. So that so if the three symbols are in the same row are same for this player, then it will return it as a true. So that is what this function is doing, and we have to check now vertically. So for that, I will just do it the same way, but instead of checking it like cell is equal to player, now I will check it like board of j of I is equal to board of um, is equal to player uh, for j in range 3. And okay, if it is true, this condition is true, then we will return it as true. So return true. And also we have to check diagonally. So for that, we will just check it like if board of 0, 0, 0 is equal to board of 1, 1 is equal to board of 2 and 2. And it should be like it is checking like if all the elements in this particular sequence, like restart the game. So if it is checking if all the elements in this particular sequence are like same, whether it belongs to X or not. That is what it is checking. And skip it player. Or if board of 0 of 2 is equal to board of like 1 of 1 is equal to board of 2 of 0 is equal to player, then we will check it, like we will return true. Now we were checking the sequence in this particular way, this particular, like in this diagonal. So this is the isWinner function. Now let's go to the another board function for checking whether game is over or not. Suppose if there are no elements to place, then that means there is no winner, it is a draw. Or if some player wins, then that means the game is over. So these are the two conditions, whether it's a draw or if someone wins. In that particular case, the game will be over. So we will write a function to check that. Is game over? The first one parameter will be board, and it will return bool, and this will check if the game is over. And so this will be based on the two conditions, either one player wins or it is a draw. And we will write logic for that. So we will check is winner of board, comma, player is equal to X, or we will check is winner of board, comma, player is equal to O, or we will check if it is a draw. That means we have to write some logic for that. If all of space not in row for row in board. This indicates like if there is no such this kind of space, that means the game is over. So it will return like the true if there is no empty space. So that is what this logic is doing. And so these are the main game functions, like the board functions, and we will utilize these board functions in our Minimax algorithm. So let's get into the main core part of the project. We will write the Minimax algorithm now. Before writing the Minimax algorithm, I would like to explain like how the Minimax algorithm is actually applied for this tic-tac-toe game, so that we can you can understand while writing code. So if the board situation is currently like this, so then we will consider like trying to apply this Minimax algorithm. Actually, if we take it empty board, then it will be a very big tree and it will be hard to explain. So I'm just taking a board at this particular state and see. So it is showing it like level 1, level 2, level 3. These are levels, and each level has one player's turn. For example, this is X's turn. So X has to put his symbol somewhere in this three points, like slots, and X is trying to maximize. And whereas O, uh, because X has taken the turn, for example, X has three spots where he can choose. So if X goes with this particular slot, you can see this slot has been taken by X. This is one condition, like one situation. Or if X takes this particular spot, then this is another situation. And if X takes this spot, this is another situation. So we are taking all the possible scenarios, where X will choose. Now X has chosen this one. We will now this is AI's turn. So AI is nothing but O. So AI has to pick up in this particular one. AI has to pick this slot or this slot. In this particular scenario, AI has to pick up either this spot or this spot. So let's see, if AI picks up this spot, then it will be occupied here like this. If AI picks up this spot, then it will be occupied here. So in the same way, AI takes up this spot here and AI takes up this spot here. So this is one level down, and next it will be X's turn again. So here X is taking his turn here and here and here. There is no other possibility. So X has to take this. So this is how the tree actually is computed inside our program. And once the like recursive function actually goes until the bottom, then it will start checking like the winning situation, like for both the players. For example, this is X's turn, and here there are some choices for X. Suppose here there is one choice, and here one choice, and here one choice, but there are no options here. There is only one thing over here, and X can't do anything. He just have to take it. So it will be the same over here. But here there are two possible situations for this particular node, and but this is O's turn, so O has to pick up something. If you see like which one O is going to take from these both two, let's see, like let's understand like what O will take. If O keeps here and here and here, then X will take this one. Here X is going to win. So O will not consider this particular situation. O will obviously go with this one because X is going to win here if O goes for this one. So based on this particular situation, O picks up this particular slot, like this particular slot, and O goes like O picks up this one. It is considering like this is safer spot, and then here in this particular graph, like in this particular node, O goes with this one, because if O goes here, O actually wins. So for O, it is like minus 100. Suppose it is plus 100, then O won't pick up because it is X's point. Like if it is plus 100, then it is beneficial for X. But if it is minus 100, that is beneficial for O. If it is 0, then it will be a draw, because if O goes here, then it will be draw. So we're keeping it like 0. But if O goes here, then it will be minus 100. So O wins here. So O is winning here. So we will keep the score as minus 100. But if for the so we have three possible situations here again. Now we will go to the upper level, so the main level, and this is X's turn. So if X has to pick up, so what he will pick up in this particular situation? Obviously, like wherever he is winning, he will pick up that situation. So X wins here. So X will pick up this slot. If he goes with either this slot or this slot, um, he will he will lose or he will get a draw. So based on all the computations, like from the bottom up, we will the player will choose the turn. So this is how the Minimax algorithm is actually applied in this tic-tac-toe game. So let's see how to actually implement this functionality in code. You go to VS Code or whatever editor you're using, and then let's start writing the function. Define Minimax, and the first one parameter will be a board, and then the second parameter will be depth, just for keeping track, and then we will see like if it is maximizing player or minimizing player. Keep maximizing player is equal, it will be a bool, and then a score will be returned. So this is the main thing, like it will return either the score by taking a move. So if we'll decide scores here, suppose if winner of board and the player is X, then the score will be -1. And if he is winner of board and player is O, so I can just remove this, it is okay, then return 1. If is game over, if no one is won but game is over board, then we will keep the score as 0 as it is draw, and we can see the same thing over here. So if X is winning, then it is -100. O is winning. Okay, O is winning here. That means it is -100. X is winning 100. In the same way, we are just keeping 3 scores in our program. And then after deciding the scores, we will see if this is maximizing player. So one player will be maximizing player and another player will be minimizing player. We will keep the best score as float of -infinity. We are getting some error because expected indent block best score is not accessed. Okay, there should be some indentation. Okay, and then are iterating over each and every row, a row in range 3, and we will iterate over each column range 3, or if is move valid board comma row comma column. We'll check if the move is valid for this particular row or column. That means we are checking whether there is some empty space in that particular slot. If there is empty slot, then we will just get like a row column is equal to 0, because this is maximizing player's turn. So I'm considering maximizing player as O, means AI. So I'm just keeping it like O, and then the score I'll try to compute it now using this Minimax. Like I'll go recursively. I'll just generate the entire tree and I'll try to get the possible scores for each possible row column value. So Minimax score is equal to Minimax of board comma depth plus 1, I'm increasing the depth, and then false, and then board of row of column is equal to empty. I'm just making it empty again, because once we make the tree, we have to just make it like we have to make it into the same position again, otherwise it will affect the game. So best score is equal to max of score comma best score, and we will return the best score here outside the entire nested loop best score. And in the same way, we will check it for the minimizing player, and the logic will be almost same, just there will be some few differences. So I'll just copy paste this thing. So this is for creating alternative turn, that kind of behavior. So like in first turn the player will be X, the second turn the player will be O. So for creating that kind of situation, like environment, we are just doing this. And here the best score will be plus infinity, and then it will be almost same, but here it should be X, and then sorry, the maximizing player is O. I forgot that, I made a mistake before. Maximizing player is O and minimizing player is X. And we are doing the same thing over here. I was just confused before. And here this is looking correct depth, and it should be true, because if it goes here once, the next iteration in the next sequence in the recursion, it should go here. And board of row of column, it is looking fine. And yeah, this is looking good. After that, this is the minimax main logic. This is the minimax function, and we will try to use this minimax function inside this find best move function. So minimax function is for getting a score by going through all the possibilities, but this find best move function is for finding the best possible move the AI can take at a particular situation. For example, if AI is in this particular situation, then it has to pick up one slot either here, here, or here. So for getting the particular like move, like for getting the particular value, like row comma column value, we will just use this function find best move. And for each of the slot, like if it is first what happens actually here is that for every move we will check the minimax function. We will write the minimax function so that it goes recursively, and it will give some score. So based on the scores which it gives, the minimax function score, we will choose some like value, like we will choose some slot. So for implementing this find best move function, create this define find best move, and then board, this the parameter like list, and then inside that it is another list, and it will contain strings, and then it will return a tuple int comma int best score is equal to float of minus infinity, and then check the best score. This is for AI, so we're keeping it like that. For row in range 3, and then for column in range 3, just going through each column, and we're checking if is best move is more valid of board comma row comma column, board of row of column is equal to, we'll put O and we will call the minimax function, minimax, and then we will pass the board and then the depth. So initially the depth will be 0 and then we are keeping it false because it is AI. And then we will just, once the score is calculated, we will keep the board state to the same column. It will be empty string, empty space. And then, yeah, this is board. This is looking fine. And now we will check if score is greater than best score, then we will consider this. So best score is equal to score, and then best verb. So did I create this best move? No, this is the best move variable. Best underscore move is equal to, it will be row, comma, column. This will be the best move. So we will keep track of the best score and best move. So once we're done with this, outside the loop, we will just give the best move. So that's why we have returned, we have kept it like this, tuple of intendant. And we will create play game function for running this, simulating this environment. So this will be the main function. Should be, yeah. So first there should be a board. Create board, and then the current player will be X because we will get the first chance. So we will keep it as X initially. So we will get the first chance whenever we start the program. It will ask us to choose the input. For that reason, we are keeping the current player as X, and then we are printing the board initially just for checking when we run the program. Board. Okay, print board. What is the problem? Prints the tic tac toe board. Okay, there is no issue. And then while not is game over of board, until the game is over, we want this program to run again and again. So if current player is equals to X, that means if it is us, then we will get the row comma column value from the input map int comma input enter, it should be a string, enter row and column. Like for example, we'll give some example like 0 comma 2, it should be separated by space, I space, then we will get the split. So if it is current player, then we want this to happen. So if you run this play game, then you will see it. So you can see the board is getting printed. After that, it is asking us to give some row and column value. For example, if I just give some value, it will ask again and again. So we have to stop this. Let's continue with the code. And after this, we will also give this else block. Then it will be an AI player. So this will be AI's turn. Row comma column is equal to, so AI is going to take the input based on this find best move function. It will return it some row and column, so we will get the value using find best move. We'll pass the board as first parameter, and then row comma column, row comma column, and then current player, obviously it will be AI, and then print the board again. Board. Okay, this is looking good. Okay, sorry, we have to print it here. Okay, let's say it. I will just take 02. It is not getting updated, so I want this to be updated. So one we have we got some row and column values for each player's turn. So we have to update the move in the board. So first we will check if the move is valid. Board, comma, row, comma, column. If move is valid, then we will make move board, comma, row, comma, column, comma, current player. And okay, once we are done with the move, so we will print the board here, and then now let's check if the board is getting updated or not. So 02, okay, it is getting updated, and AI's turn. Actually, AI has to update the board. I'm not sure if AI updated or not. Okay, AI's turn is not getting updated. Let's check why it is not getting updated. Okay, if game is over, then it's going here. Let's print something here. Print F AI's move row and column. This is fine. Then we will check if AI is going or not. 0 2 sorry 0 space 2 is going, but it is not going to the AI's position. We will correct it. So what is the issue here? Let's see. Okay, actually the logic for switching out the current player is not there. That's why it is not working. It is just giving us every time the chance. So we will write this logic function if it is current player is O, like if current player is X, if current player equals to X, then 0 will be returned, means it will be A's turn. Otherwise, it will be X's turn. So if we run it now you can see, okay, the move is taken, but there is some error. Find best move takes one positional argument, but 4 are given. Find best move. And yeah, find best of board. We don't have to provide all these things. Now let's run it again. 0 2, and you can see AI is choosing some turn now. If I go with 1 comma 1, AI is choosing something else. So the program is working pretty good. But one thing we have to do is we have to decide if the game is over. But one thing we have to see when the game is getting over, because the logic is not there, so it will go on continuously, and at the end it will throw some error. So we should write that logic here, like if is winner of any player, like board comma current player, then print f current player wins. This will be the logic, and then the program should stop. This is looking good. There is this if condition, else condition. This is good. Okay. If all these things, if this didn't work, that means it's a tie. So let's write logic for that. For this if condition, we will write this else block, else print. So if move is valid, then it will go on. But if move is not valid, then we have to print like invalid move. Try again. And here we'll write some else block, like print. It's a tie. Save. And now let's run the program. So let's take 0, 1. Okay, AI took some position. Now take 2. AI took another position. Let's make AI win. So I'll take some bad move. So I will pick up this center position, which will be 1, 1. And then I will pick up this 2, 1. Okay, I actually won. Next one. Let's try again. 2, 2. Then 1, 2. Then I will take this 2, 0. Trying to block this. AI tried to block me. I tried. Xfins, because this program is not working fine. We have to correct the logic somewhere in the program. There's some issue. So let's correct it. Okay, the issue here is that like we have to take minimum. That is the issue. If I run it now, I think this should work fine now. Okay, I will pick up this lot like 2, 2. AI blocked it. This is working fine. I will try to make AI win. So I'll take 2, 1. Okay, AI is winning. So now I will try to win 1, 1. This is the best position I feel. And then I will take 2, 0. Okay, AI blocked it. So I will take 0, 1. Okay, I blocked AI's position. So AI blocked mine. And what is the move? What possible move? Okay, I can go here. It is not good. And I can go either here or here. But okay, these are the two good slots for me. So I will go here so that AI, it will be a draw, I guess. So 1, 2. And then AI blocked this. So it is a draw. 2, 2. Yeah, it's a tie. So as you can see, the program is working fine. Even if you test it many times, you will see that either you will lose or it will be a tie, but AI will never let you win. So we have implemented our Tic Tac Toe game using Minimax algorithm, and this is working really well. You can test it out. You can play some games with it, and you should notice that AI is unbeatable. Now you will either lose or tie, but never win. So the AI under the hood is evaluating every possible move by simulating all possible outcomes of the game and assigning a score to each outcome. A positive score represents a favorable outcome for the AI, while a negative score represents favorable outcome for the human. So based on the score, AI chooses the move with the highest score, ensuring the best possible outcome for itself. So that's all for the Minimax algorithm. It is working really well. If you want to optimize, there is some pruning algorithms for that. You can check it out. Thank you so much for watching the entire project. I hope you liked it. Thank you.